In the last video, I mentioned the unofficial distinction between arrays and matrices. In this video, I'm going to focus on operations done to arrays. These are commands that treat their arguments like tables of numbers having no particular properties. I'm going to define a few arrays to mess around with. As you would expect, arrays are added and subtracted entry-wise. As a convenience, if you add a number to an array, it's added to every entry of the array. This last property also holds for multiplication and division of an array by a number. However, if you want to multiply or divide two arrays entry-wise, you have to use dotted forms of the operators. You can put numbers in place of the arrays. Nothing interesting happens for these operators except when you do a number in front of the dot slash. For example, if you do 1 dot slash t, that takes 1 over each element of the array t. The dot caret operator raises all the entries of one array to the powers given by the entries of the other array. You can also use the dot caret with a number as the exponent, and it does what you expect. You can even put the number on the other side of the dot caret, which has some interesting uses. For example, I can raise -1 to the power of everything in the array t by saying -1 dot caret t. If you try to use the caret by itself with a numerical exponent, you will get an error if the dimensions don't agree. But be warned, if you use the caret on a square-shaped array, then Matlab will interpret that array as a matrix and give you an answer, just not the answer of raising every entry of the array to the given power. So if I say m caret 2, that does not simply square every element of m. I have to use m dot caret 2 for that. When you try to do one of the array operations above with two differently sized arrays, you might get an error. But sometimes you get a result. If you look carefully, you'll see that the single column v in this example has been added to each column of S. This idea where multiple copies of a vector are used to match the shape of the other array is known as broadcasting v. This has some interesting uses. For example, I can find the differences between all pairs of elements in V by doing a sort of double broadcast. In this case, the first vector v was broadcast 3 times horizontally to match the number of columns in V transpose. Likewise, V transpose was broadcast 3 times vertically to match the number of rows in the first array V. As the last category of array operators, I want to talk about some reduction commands that operate and collapse along one dimension of an array. For example, I can sum along the first dimension of S by saying sum S1. If I say sum S2, it sums along the second dimension, which is the column dimension. Other commands that work like this are prod for products, mean for averages, and min and max to find minimum or maximum elements. For example, I can subtract the column average from every row of an array by saying m minus mean of m1. That does one of these reduction operators followed by a column broadcast. That's enough on array operations for now. In the next video, I talk about operations designed to work on matrices.